Okay, year 13, I thought I'd just give you a sort of online lesson to reinforce what we did today. This is the same example, but I'm sure some of you will really need to think about going through this again. So we're finding the areas between curves. And what I've gone and done here is I've drawn y equals x squared, parabola like that, just touching the origin, one which you're all very familiar with. And overlapping it, we've got the inverted parabola, which is y equals minus x squared plus 4. Okay, minus x squared, because it's inverted, it goes like that. But because there's a plus 4 on the end, it's been moved up 4 units, which is why it crosses the y-axis there at 4. However, what that means is that there is an overlap between the two parabolas. Well, how on earth do you find that area? You can only do it with calculus. You'll notice that the area is bounded by curves. That's a curve, and that's a curve, okay? And you need and can only use calculus. Now, the first thing I'm going to try and explain, I now have not done the algebra for it at the side, but I will try and make it clear. You may ask, where does this root 2 come from, where the graphs intersect there and there? Why is that negative root 2 and why is that positive root 2? Well, when two graphs intersect like this, then their y values there at that point, their y values and their x values have to be the same, okay? And if at that point where they intersect, the y and x values are the same, then you can set this x squared equal to this minus x squared plus 4. Because the two curves at that point share the same y value. So that y equals that y. So you can set that x squared equal to this minus x squared plus 4. If that's the case, you could take the minus x squared over the equal sign with that one, and then it would go to plus, and of course then we'd have plus 2x squared. If you divide both sides by 2, you just get x squared is equal to 4 divided by 2 on this side, which becomes 2. So you end up with x squared equals 2. So you find x by square rooting that. And so you say that x is equal to plus or minus the square root of 2. They're the two solutions of the little quadratic equation you're playing around with. And they are the values there and there. In other words, these are the x values where the graphs intersect there and there. But these are going to provide our limits of integration, which is why they're important to find. All right, now, so how do we do this? Well, if we think about the area that is enclosed by this parabola completely, and then we think about the area underneath this parabola, the only two limits we've got to think about are these two limits, there and there. All right, so what I've gone and done is I've split them up like that. Okay, if I bring that down a wee bit there so you can see it. Yes. So this one here is the normal y equals x squared. Okay, and if we find the area underneath this between minus root 2 and root 2, we will get this area here, this one here, and that one there. We've called that area P. Now, if, on the other hand, I look at the parabola, the inverted parabola at the top between these two limits, root 2 and minus root 2, clearly, if I integrate this curve here, this one here, y equals minus x squared plus 4, between minus root 2 and root 2, I'll get the entire area underneath this parabola from there to there. That, of course, is not the area we want. We want this area here that's the area of overlap. Well, I hope you can see that when we take area OP, this area we found here, away from area Q, we will indeed get that area of overlap. So that's exactly what we say. We take area P away from Q, and that will leave us with the area A that we're interested in finding. Okay, so we're going to have to integrate underneath, we're going to have to integrate y equals x squared from minus root 2 to root 2. So it would look like this. There's the area P, and we're integrating from minus root 2 to 2 of x squared dx. Well, that becomes x cubed over 3. And there's the limits, minus root 2 and root 2. So now we put these limits, starting with the upper limit here, positive root 2, we put it in place of the x. There it is there, all cubed. Divided by 3, minus, now we're going to place this lower limit of minus root 2 in place of x there. There it is there. And it's all cubed, divided by 3. Now, this, when we cube a negative number, it comes out negative, but when it multiplies this negative, it's going to come out positive. Now, you'll notice, I hope, that the value of this part of the area is exactly the same as this part of the area, only this part comes out negative. Makes no difference, but what that really means is that it's because of the symmetry of the graph y equals x squared, that because it's symmetrical either side of the y-axis, the areas, this would, of course, this part of your integral here, this will work out as a negative area, the negative area, but exactly the same size as this positive area here, because they are symmetrical about the y-axis. But that minus sign and this minus sign in this case go to plus to give us the total area from minus root 2 to root 2. Now we do the same thing for the other area here, the area which I called Q. Okay, it's the area underneath minus y equals x squared plus 4 from minus root 2 to 2. So there it is there. There's the limits. And now we integrate this. We get minus x cubed over 3 plus 4x. And there's our limits again there and there. We now substitute in the limits, root 2, positive root 2 all cubed. Don't forget that minus sign to write it in there. Plus 4 root 2. So we put in the limits of positive root 2 for x and x cubed there and there. Now we go minus. We have to be super careful here with all these minuses, okay? So we now write a brackets. Now that minus is that one there, okay? So you're going to need another brackets because you're now substituting in a minus or a negative root 2. So there's my substitution, the negative root 2. And it's all cubed. It's all divided by 3. And then plus, that's that plus there, 4 times this limit here of negative root 2. And when you work all of that out and you're super careful with your signs, you should find that inside this brackets, it will come to negative 4.714 something, something, something. Well, of course, if it's negative inside the brackets, this negative sign here is going to change the whole thing to positive there. Okay, and this also comes out to be the same thing. And again, notice that this is the same value as this. Why? Because this graph here is symmetrical about the y-axis. So when I add them together, I get this value here. Now, as we said before, up here, the area that we want, the area P, must be the area of Q minus the area of P. And that's exactly what we do here. And the final area that we're after, the area of overlap between those two parabolas, is 7.5423. Now, those little dots there mean it does go on forever. So I've written it to 4 decimal places, which is quite accurate. Okay. I think that's the end of this video. Let me just see where I don't have enough time to start the next one. So I'll do the next one on another video. All right. Thank you very much.